Morning, everyone. Sit down. Are you surprised to see me today? How many of you are aware that timetable has got changed? Everybody? That's good, because sometimes students are not aware and the changes take place at the last moment. So this is it. So anybody, if you have any doubts on machine, you can ask. Or else we'll go to the next step. So anyone has any doubt? You will realize, yes, most of the questions are from selling out, right? Most of it, except the application type and the previous year questions. Previous year questions, these are from the actual board papers. Yes. So how many of you brought your homework notebooks? You brought your homework notebook? You haven't written anything. What's the meaning of that? Yes.
Sir,
Yes.
I want to inform you that I'll be only attending the
You will be attending what? Say that
first two lectures.
only what?
First two lectures, sir.
You have only attended first two lectures.
No, sir, I will today attend only first two lectures.
That's fine. So first two will cover physics. So I'm okay.
So
First two means only first two, right? After this break, that's fine. I'm okay with that. But you need to inform the other teacher. Okay. Yes. So, okay, raise your hand. How many of you are religiously doing the homework? Nobody. So I'm going to write a feedback to your parents now. Right? You got to do the homework also. Classwork is just you come to learn the tricks. But whether you actually have understood or not, right? You will be able to self-assess yourself only after doing the homework. So nobody has done homework, right? Except you, I got you. What about others? Others, what? Who are doing wrong? Selena. That's fine. But what about extra questions? There are so many extra questions. Previous year board questions, MCQs. Selena also has MCQs, right? Okay. So I expect you to do that. Otherwise, some remark is going to go to your parents. All right, we'll start the next chapter, which is reflection of light. This chapter 4. How many schools have started this chapter? Any school has started this chapter? What only Ryan has like gone quite ahead. Few chapters are remaining. Some other school. Some school. They have almost completed. Just one or two topics remaining. I don't know how they've gone. Students have not understood anything. They're not able to solve the mathematics. But when I asked, school has completed everything. So what does this mean? Okay, so let's start with refraction of light. Are you familiar with this term in lower classes also? Have you studied about it? So what is your understanding? What's refraction of light? Refraction.
The light travels to a different medium with light and changes its
Direction in the second medium, right? So there are refraction of light. First topic is on plane surfaces. In this chapter, we will learn about refraction of light on or biplane surfaces, at plane surfaces. What's the difference between on and at? English experts. When to use on and when to use at? Is there any difference if I say on or at? Is there any subtle nuance? Okay, so which we use them. Okay. So I'll illustrate it with the help of an example. Let us say we have two transparent mediums, right? So we often experience air, water, and glass. These are the three transparent medium we are dealing with on a daily basis. Right? Like I can see person standing outside the door to the glass window. So light is traveling from air to glass to air, right? Somebody inside the swimming pool, swimming inside, okay, below the water, looks at the object outside. Okay. So he is looking through water and then to air, right? While looking into wearing specs, right? So it is water, glass, air. So these three combinations you come across on a regular basis, right? Because of that, what are the phenomena that we'll see in this chapter, right? So basically what happens, whenever light travels from one transparent medium, say air, to another transparent medium, say glass, right? So the direction of its path changes in the second medium. This is what happens in light. Right? Whenever light travels from one medium to other medium, the direction of its path, what was the original direction? This was the direction. Right? But the direction in the other medium changes. Now, how it changes, like whether it goes towards the normal or away from the normal, there is a rule for it. So we'll see that. Okay? So first, let us become familiar with the angles. So this is the point of incidence. Let's call this as O. This point O. This is the normal. And P, O, Q. Right? This is the angle of refraction. Now this is the angle of refraction. It's not reflection. Right? So this phenomena of change of direction of light when it enters the second transparent medium is called refraction of light. Okay, this phenomena itself is called refraction of light. Right? Now, does the light passes 100%? Does it pass 100%? No. Some amount of light is also reflected. Some amount is reflected also. So let's call this as R dash. This is called partial reflection. Okay. So this let us call P dash. So let us write down what is what. So PO is incident ray. Then OP dash is partially reflected ray. Then O is point of incidence. Point of incidence. Where is this point of incidence? On the boundary separating the two mediums. Okay, so it is on the point of incidence, right? What is AB? It is called the refracting surface. Okay, so it is the boundary or a surface phenomena. Refraction is a boundary or surface phenomena. Whenever the medium changes, it happens over there, right? So it is after point O, the direction changes. So what is this medium? The second medium, glass is, it is called the refracting medium. Whenever the direction changes, this medium is refracting medium. Okay, the second medium is refracting medium. What is the first medium? It is called the incident medium. Right. Now, air is rarer. It's a rarer medium. Whereas glass is a denser medium. So many differences. What kind of density? Optical density. The density we are talking about is not mass density. What kind of density? Optical density. We'll learn in a minute what is the meaning of optical density. Optically rarer. This is optically dense. Optically rarer medium is that medium in which the light speed of light is more. If the speed of light in the medium is more, that medium is optically less denser. Right? And wherever the speed of light reduces, that medium is optically denser medium. Okay? So relatively, let us say you have various medium. One is more optically denser than the other. Right? Let's say medium one is optically less denser and medium two is optically more denser. Where the speed of light will be less. First or second medium? Second medium, right? So now the rule. The light ray will slow down in the second medium, and because it is slowing down, therefore it will bend towards the normal. Okay? If the light is entering fast, I mean if it becomes fast in the second medium, then it will increase the speed and it will go away from the normal. Like if the light was entering from here to here, now suddenly speed increases, it goes away from the normal. Okay? Whereas when it slows down, it turns towards the normal. It entered fast but now slowed down, so it turns towards the normal. Is the logic clear? Right. So we'll come to that again. So what is AB? AB is refracting surface. This OQ. OQ is refracted ray. let's mention all the angles now. This is the angle of deviation. The angle I is angle of incidence. R is angle of refraction. Angle R dash is angle of reflection. Right? So I is equal to R dash. The law of reflection is obeyed. Okay? Which angle is remaining now? Angle delta. This is called angle of deviation. Angle of deviation. Right? So deviation is the angle between the emergent ray or the refracted ray and the direction of original incident ray. Okay? So this is called angle of deviation. This is, it is deviated by this angle from the original path. Okay. So write down clear. The opposite angle. I is equal to R everywhere. Symmetry is everywhere. Reflection. This is for the first time I've told. Now we will not show the reflected. We will only be dealing with the reflected part. Okay. Reflected. All symmetric words. This is a refraction of light. I have just the region. That's good. That's what they- that's what I did. The direction changes. Speed of light is dependent. When I said that the light slows down and goes towards now, then it doesn't, then it goes straight. It's the reason is difference in the speed of light in different mediums. Actually, light is difference. Speed of light is maximum in vacuum. This you need to remember, speed of light is maximum in vacuum. And it is taken the same in air also. Or slightly less in air, but approximately the same. Okay. All other mediums it is less than C. Light enters from air any medium is supposed to went towards except air or vacuum. All other mediums are really dense. Hey, is this part? Yes, online students, can I erase this part? Or which way? So bending of light. So if you are familiar with these rules, bending is according to what are written there. Whenever the right actor from completely error, completely density, right? Words are wrong. Whenever it bends, whenever it enters from denser to error, it will go away from it. That's the rule. Did you write what is NON dash? In what I had given? NON dash is the normal. And dash. And dash. And dash. Henceforth, we will now not be drawing the partially reflected ray. Since we are going to learn about refraction, next diagram onwards, okay? This diagram that you have drawn is fine. What we are going to discuss next is, we'll consider this diagram. And we'll now write laws of reflection. Just like you had laws of reflection of light, we also have its spelling. Okay. Right? Correct it is. Enters, enters. It's not enters. Enters. So I stand corrected. It is not enters. It's enters. Thanks for that. Okay, we will let's see this. Without writing. Refraction. The laws of refraction has two parts, just like you had laws of reflection. So anybody remembers laws of reflection? What are the laws of reflection? Angle of incidence is equal to angle of reflection. And the second part? Parallel. Yes. On the same surface, same plane. The incident ray, the reflected ray, and the normal at the point of incidence remain in the same plane. What is the plane here? Huh? Plane is the board. The board itself is the plane. Because everything else is, we can render it out of the board. So the plane is the board. Right? Now, similar lines, here laws of refraction. But here is the angle of incidence equal to angle of refraction? No. Right? So the first part of the law is same as law of reflection, which is the incident ray the refracted ray and the normal at the point of incidence. Okay, lie in same plane. What does this mean, lie in same plane? Okay, lie in same plane means this. Can everybody see this? Was this the surface? Can everybody see this? Let me show you over here. Let's say this is the refracting surface. Okay, so this surface separates air. This is the boundary, correct? Now you have the plane here. This is one plane, right? So incident ray, the normal and the refracted ray lie in this plane, Okay. Now if I change the plane, how can I change the plane? Rotate it like this. Okay. So I rotate it like this. Now the incident ray, the normal, only the point of incidence remains same now, and the refracted is now in this plane. This plane and this plane are different. Understood? It is rotated on the vertical axis. Only point of incidence is common. Understood? Okay? So this is the meaning of it lies in the same plane. जिसमें इंसिडेंट होगा उसी में रिफ्लेक्ट होगा. अगर यहाँ पे इंसिडेंट हो रहा है तो यहाँ रिफ्लेक्ट होगा. Not the original plane. Understood? This is the meaning of it. Now second law is also another law. So it is a law within the law. The second part of law of reflection is called Snell's law. Okay. The second part of law of refraction is called Snell's law. What is Snell's law? It states that okay, what does it state? It states that sine of angle of incidence, ratio of sine of angle of incidence to the sine of angle of refraction, always constant. Always constant for a given pair of refracting medium at a given wavelength of light. Sin I by sin R equal to constant for a given pair of medium and a given wavelength what does the wavelength of light signify? Color. Okay. What is Snell's law? Wavelength of light, मतलब single color monochromatic. To change the color of light, you will get a different angle of refraction for the same pair of light. This has to be satisfied simultaneously. This is Snell's law. What is this constant? This constant is for a specific name. This constant is written as N21. Mu2, that's right. Mu2. Right. In index. Second medium. With respect to this is constant known as this constant is known as refractive index of the second medium with respect to first medium. What will you write it? Q1. One is the subscript. Q1. Therefore, sin I by sin R equal to Mu2 1. Are we good till here? Now let us learn principle of reversibility of light. law, reversibility of light. What is principle of reversibility of light? Now look here. What is principle of reversibility of light? Let us say the light is passing from the first medium to second medium. Right? If I just reverse the direction of light, let us say I put a mirror here. Let's say I put a mirror here. And place it such that the refracted ray hits the mirror along its normal. And what will happen? What will happen? Huh? So it should return by following the same direction. This is the principle. Okay, so what is the principle? When the direction of light is reversed, during refraction, it retraces the same path. What is reversibility of light? During refraction of light, if the direction of light is reversed, it will retrace the same path. Let me write the refracted, the reversed path with two directions. Is reversed. It will retrace the same path. Now, in this situation, when the path is reversed, yes, what confluence is going on? In this situation, when the path is reversed, what is the Snell's law when the light is traveling from second to first medium? What is the Snell's law? How will you write the Snell's law? How did you write this? When the light was traveling from first medium to second medium, how did you write the Snell's law? You wrote it like this. What will be Snell's law when the light is traveling from second to first medium? Or the reverse path? See this carefully and then state the law for this situation. Sit loud. Sin I. What is angle of incidence when the light is traveling like this? So it will be sin R over sin I. That will be equal to what? U12. Okay, so the Snell's law changes here. So what is the Snell's law for the reverse ray? For the direction of okay, by reversibility of light. Sin R upon sin I is equal to mu12. Correct? Sin R upon sin I is equal to mu12. So how will you read this as? How will you read mu12? It is read as this time. How you will read this? Refractive index of first medium with respect to second medium. उल्टा हो जाता है. If you change the direction of light, you will read it as. Abhi, what is the refracting medium when the light is traveling like this? What is the refracting medium? Are you listening? What is the refracting medium in the second case? First one. It is always the second. Wherever the direction changes, this is the original path now. Direction changes here. That's why refractive index of first medium with respect to second medium. In this case, the second medium is the incident medium. First medium is the refracting medium. Okay. So get this concept very clear. So now, what is the relation between this and this? What is the relation between mu21 and mu12? They are reciprocal of each other, right? So this is 1, and this is 2. So from 1 and 2, mu12 is equal to 1 upon mu1. So by reversibility of light, what is the relation? mu12 is equal to 1 upon mu1. Very important relation. Is concept of absolute refractive index. Having understood what is the refractive index, I will study about what is called as absolute refractive index. Want everybody to write till here before I proceed further. And if there are any questions, get it clear before we proceed further. The thing to be understood in this chapter is what we are discussing right. Rest is purely application. So learning is only here. If you have any questions still here, you can ask. So, yes. Speak louder. That's what I'm saying. From 1 and 2. What is 1? Sin I by sin R. What is reciprocal of sin I by sin R? Sin R by sin I. That's what it is. And how did we get this? By principle of reversibility. When the light is going from here to here, what is the angle of incidence? R. What is the angle of refraction? I. So now for this case, it is sin R by sin I. And then how the refractive index is written? It is written for the refracting medium. What is the refracting medium? I. Okay, 1. What is the refracting medium? 1. Now the light is traveling from denser to rarer. So the Snell's law becomes like this. Okay. And what is the relation between this and this? They are reciprocal of each other. Okay. So when you swap the medium, the refractive index becomes reciprocal. Is that clear? Next is, let us understand what is absolute refractive index. Now, absolute refractive index is just a definition. What definition? The first medium now becomes fixed. It is air or vacuum. When the first medium is always air or vacuum, the refractive index of the second medium is called its absolute refractive index. Okay. So, what is absolute refractive index? When the incident medium that is the first medium is air or vacuum. The refractive index absolute refractive index of the second medium. Now, sometimes the subscript is not written as number, sometimes it is written as the first letter of the medium's name. Like, or it can be also written as, what is this? Air glass is equal to 1 by glass air. A stands for air, G stands for glass. Okay, so in numericals, you may find the refractive index symbol with either number or alphabets. Then the alphabets represent the name of the mediums. Somewhere, if it is water, W, that stands for water. Okay. If you get W, then it is water. Okay. That is, in that case, okay. So then the second medium is not mentioned. Okay. When the incident medium is air or vacuum, the refractive index is called the absolute refractive index of the second medium. Okay. In that case, we don't mention the incident medium. That is the incident medium. The first or incident medium is okay. In case of absolute refractive index, we don't mention the first medium. We reference this. The first medium is air. We don't mention the first How do we differentiate when both the mediums are written? Only one medium is written. That on a 3 to 10 years plate scale is very good. So it is not configured. So is the concept of absolute refractive index understood? To differentiate absolute refractive index when both mediums are measured, it is what relative refractive index. But you write it as being 1 to 1, it is what relative refractive index. And when it is written just with the medium, it is absolute refractive. Are we good till here? We are only now setting the foundations for this chapter. Not done yet. Okay, the next concept. What is RI? Refractive index. It has another definition as well. One definition is sin I by sin R. The other definition is RI of RI is RI of pair of medium. Is also defined as ratio of speed of light in the first medium. So light in the second medium. That is part. Okay, there is another definition for refractive index. It is defined as the ratio of speed of light in the first medium. The speed of light in the second medium. Okay, so where what is first medium and what is second medium? I know you understand it. What is first medium? Second medium. What is first medium? Second medium. Second medium is direct medium. First and second is direct. Sometimes every one that is the refractive, every the written here. What is first medium? Is the second medium. So any questions till here? What is this? Is equal to C by first of the speed is C. Okay, so first medium is air. Understand? Okay, so get used to this now. So now second medium is not, first medium is not mentioned. You have to understand the first medium is air. Okay, this is what it is. What is C and what is V? C is the speed of light in the first medium, which is air. And V is the speed of light in this medium, where its direction is changing. Is that clear? Now V1, V2 is written when this medium is, none of them are air. Right? So this could be how it can be written. Let us say the light is traveling from water to glass. When I write this, when I write mu GW, what does it mean? Light is traveling from water to glass. Glass is the second medium. So how will you write here? It will be VW upon VG. Write these examples. These are the examples in which there is no air medium. Okay, there will be situations when there is no air medium involved, water to glass. Like when fish is watching you. Okay, here's the scenario. In the fish tank, fish is watching you. What is the direction of light? What fish? And fish is watching you. What is the direction of what medium? What was glass? Fish is watching you. Fish tank, there to glass to watch. Can you want? Okay. The flat is still up. This is the blast point. Take a fun girl. And when you are watching the fish, she is watching the fish. Fish. And what is the path of light? Now, this medium to this medium. How do you see object? When light ray reaches high. Water, glass, air. So get used to it. Right? So now the learning is done. Now we'll apply all the concepts that we have learned. So what have we learned so far? What have we learned so far since morning? Snell's law. So what is the incident medium? What is refracting medium? Right? Then Snell's law relates. What does it relate? What does it relate? The refractive index of the medium with the speed of light in different mediums. Okay, this is what we have learned so far. Refractive index is nothing but the factor with which the speed of light varies in different mediums. Understood? What is the meaning of refractive index? It is just the factor with which the light speed changes when it passes from one medium to other medium. So, for example, what is the refractive index of glass? It is roughly 1.5. Refractive index of water is roughly 1.33. Okay, so what does it tell you? What is the refractive index of air? It is just 1. Okay, likewise, the refractive index of diamond about 2.42. So, what does this tell you? Higher the refractive index, lower the speed of light in that medium. So, refractive index is lowest for air. So, speed of light is fastest in air. So, value of refractive index tells you, high value of refractive index tells you the speed of light is low by that factor. For example, if I write this, what can I write? This is nothing but, correct? And what is this? C by V. C is the light in air and this is speed of light in water. So this is what? 1.33, which means C by 1.33. What is C? So this is the factor by which the speed of light reduces in water. Is the meaning of refractive index clear? Okay. It gives you the factor by which the speed of light will reduce in this medium. Okay?
What is that task?
Diamond.
That fourth medium here.
Diamond. So speed of light is slowest in diamond. You get it? Now, we can experimentally calculate the refractive index. Lab में निकाल सकते हैं. So I'll tell you that also. But right now, first you get used to of this terminology. Refractive index का मतलब क्या है? It actually just tells you the factor by which the speed of light is going to reduce in the medium discussed. Fastest in air. ये clear हो गया? It is also related with the bending of light. So which medium will bend the light more? The one with higher refractive index or lesser? Higher, because what is refractive index? देखो, refractive index is also equal to sin I by sin R. So when will it be greater? When R is less than I. When will be the bending more? When R is small. Small value of R will make the denominator small. Sin small value is small number. Sin 0 is 0. Sin 30 is 1 by 2. Okay, sin 90 is 1. Right? So this angle, जितना छोटा होगा उतना sin की value छोटी होगी. Small r means more bending. So जितना r छोटा होगा उतना ये बड़ा होगा. Clear? Okay, so everything is now making sense to you, hopefully. So with practice it will, right? Now let's go further. Relation between relative refractive index and absolute refractive index. When we mention both the mediums, it is called relative refractive index. And when it is only one medium, that means it is with respect to air. That is called absolute refractive index. So what is the relation now? देखो. This you know by definition. What is mu to 1? V1 by V2. So I will now multiply and divide by C. What have I done? Just multiplied and divided by C, the speed of light in air. Now I will rearrange. Can I do this? C upon V2 and V1 को मैंने नीचे ले लिया. Can I do this? Now what is this by definition? What is C by V2? V2. And what is C by V1? V1. So what result did I get? So I get mu to 1 is equal to so this is the relation between relative refractive index with absolute refractive index. The example is okay. So now when you have refractive index, on the left you have relative refractive index, on the right you have absolute refractive index. Okay. So we can also write this as mu GW is equal to mu GA into mu AW. Can we write it like this? What is it? This is C by VG. What is this? By VA. Oh, yeah. Oh, okay. Yes, this is correct. Isn't it? So these are various different ways in which the relations of refractive index can be written. Maximum numericals are on this, whatever we have discussed. You have to learn the variety of ways the refractive index is expressed. Okay. We only applied, there's no difference between this and this. One is expressed in terms of absolute refractive index, the other one is expressed in terms of speeds of light. Okay, so I will now summarize all that we have done so far. Write down summary of RI formulas. So one, sometimes even the second medium is dropped. Okay, because now it is refractive index of the medium. So जो medium है उसी का refractive index. Okay, sometimes even that is dropped. 4. That's it. So these are the 5 formulas we have done so far. But the hard part is over. These 5 things. ये समझ में आ गया तो फिर आगे सब कुछ easy है. Okay, shall we go further? In your book, there is a table in which refractive index of various substances is given to you. Okay, the value only tells you about by how much the light ray will bend in closed medium. जिसका ज़्यादा है वहाँ पे ज़्यादा bending हो. ठीक है, so many mediums are bending. So far we discussed about bending of light. Now can you tell me when light passes from one medium to the other medium, when it will not bend? हाँ? हाँ, 2 केस में bend नहीं होगा. Conditions for no deviation. Angle I equal to 0. That is ray incident along normal. Okay, ray incident along normal and both mediums have same refractive index. Okay, so second case is hypothetical. right? If both mediums have same refractive index, then the mediums are same only. What is it? Whose bag is this? Okay, so the possibility for ray not to deviate is only when both mediums have same refractive index, or when the ray is incident along the normal. Okay, so देखो when the ray is incident along the normal, it will pass straight, no deviation, right? Also, when 1 and 2 are same medium, then also no deviation. So the other thing is okay, when mu1 is equal to mu2, both mediums have same refractive index, then again there will be no deviation. Now we'll discuss what are the factors that affect Ri of the medium. What are the factors? What are the factors that will affect the bending of light? One is obviously nature of medium, which is optical density, right? One is nature of the medium. That is its optical density. What else? Wavelength also, correct? The colors, wavelength or color of light. So when you do the experiment, you will find that the red light, what are the various colors you have? You have pure, right? You'll find that the angle of deviation for red is least, and the angle of deviation for violet color is maximum. Let us say this is R. So experimentally, it is found that U. What does this mean? If the deviation for violet color is maximum, that means it travels in the medium with least speed, whereas red color travels with fastest speed in the medium. Okay, so it is about the speed because refractive index or bending is the reflection of or indicator of refractive index. So what about V? VR will be greater than V violet. In terms of wavelength, what is the wavelength of violet color? Wavelength of violet color is smallest. Red color is maximum. This is the wavelength. Lambda R. So what about wavelength? Lambda R is greater than V. Okay. What does this tell you? This tells you bending for R is least. This means wavelength is inversely proportional to the refractive index. This is the relation. Higher wavelength means or mu is inversely proportional to wavelength. Both are one and the same thing. Higher the wavelength, lower the bending. Lower the bending means the refractive index is less. Or light of higher wavelength. That clear? You're able to absorb the concepts that we discussed just now. If not, ask. Tell me, what is the effect of wavelength on refractive index? Is the medium changing here? Is the medium changing here? No, it is the same medium, right? So what are we changing here? The color of light. And you are observing experimentally that the bendings are different. Huh? What is height low?
The last
And the wavelength is large. Then the bending is more or less? Less. क्यों? क्योंकि उसके लिए refractive index कम हो जाता है. Yeah? There is inverse relation. Maximum, yeah. Among the pure, red light has maximum wavelength. And it is not exact. It could be plus minus 1000 or plus minus 100. What is mentioned on the board is angle of deviation, velocities, and wavelength of respective colors of white light. Okay. And the third factor is temperature. There is one more factor on which it also depends on temperature. So when you heat the medium, it will expand. So its optical density will reduce. So what should happen? The deviation will increase or decrease with temperature. Huh? With temperature, what happens to the refractive index? Huh?
The bending will decrease and the temperature increase.
Yes. So what does it mean? What happens to the refractive index then? Huh?
It decreases.
D or in decrease? With temperature, it will decrease or increase? I'm not able to understand what you're saying.
I'm saying decreases.
Decreases, correct. With temperature, the refractive index will decrease, obviously. Because now the optical density is reducing. Expand over a medium. Okay? So ultimately everything boils down to refractive index. Whether it is temperature or wavelength, you have to figure out what happens to refractive index. Clear? All right. Now we will also discuss we will discuss the effects of speed and wavelength. Yes, let's pull your back.